Hello, guys. Welcome to the series of workshop. So, as part of this series, this is episode 2, and in this episode, we are going to see a practical hands-on demo in which we are going to see how we can use Hashicorp Vault with Kubernetes clusters. So, the agenda for today's specific video is, or I would say, demo or workshop is. Ashish is going to come on board and he's going to show us that how we can utilize HashiCorp Vault with Kubernetes cluster to store the secrets whichever are required as part of that cluster operations and have to be stored as part of the vault. So without wasting much time, let me go ahead and introduce our speaker. That would be Ashish. Hi Ashish, how are you
Hi,
doing today?
I'm doing good. How are you?
I'm also doing good. So Ashish, without wasting much time, so I think it's time for us to get started. So uh, over to you, Ashish.
Sure, just a minute. Screen. Okay, so is my screen visible now?
Yes, Ashish.
Okay, so as Dheeraj said, today we will be looking at how we can leverage HashiCorp Vault with Kubernetes to hide all our secrets and everything. So by default, when everyone starts, what they use is they just use Kubernetes secrets. Then we have other alternatives like Secrets Manager and your Google Secrets Manager and other third-party options. But today we are going to look at HashiCorp Vault. So today our agenda would be we would go through some theoretical part first, then we would jump on to implementation, and in the end we will wait for some Q&A. So first of all, let's understand what is secret management and why do we actually need it. So secret management is the practice of securely storing, distributing, and rotating sensitive information like our API keys, passwords, certificates, PKI keys, SSH keys, and etc. And when you go on the production workload, you don't want the world to see your secrets. You don't why we use secrets. And also when you are going for compliance standards, you need to have a robust secret management strategy. For this, people tend to have different approaches. Some people use cloud provided tools like integrated in AWS, like they use a combination of KMS and secrets manager, or they go with Azure Key Vault and like CyberArk, Confidant, Mozilla SOPs. There are many options available, but we will look at HashiCorp today. And so what happens in secret management. So what we are going to do is we are not only going to store our secrets, but we are also going to encrypt it, so that even if someone gets access to our, let's say by chance gets access to our vault, they are not able to access the secrets directly. It's not in plain text. And in that we will look at hashing, salt hashing, etc., and other things. And we would also do for in DevOps, we also know that we need to follow least privilege. So over here we would also do that using RBAC. So HashiCorp Vault supports RBAC, role-based access control, wherein we will create access control lists and roles for each of the identities. Identities can be a user, a machine, or a service, etc. So moving on, as I told, there are these kind of tools available in the market. So there would be actually there would be 4 types in actual: open source, proprietary, self-hosted, and cloud hosted. But if you take them majorly, they come in under 2 topics: open source and proprietary. So all of them do the same thing, secret management, but it's just like some features are there in Mozilla SOPs, Confidant, or sealed secrets, and some are not. So that is why it's up to your requirement which you choose. So let me just brief you about these tools that I have already mentioned. So in proprietary, if you are using any cloud platform, you would already should be aware of AWS Secrets Manager, Azure Key Vault. So these are like basic secret storing things. Like you just go put in a JSON file or in a JSON format and you save your secrets. Then in your open source, these can be easily self-hosted on your virtual machines or as containers. So sealed secrets is one of those open source tools that is quite known in the market for encrypting your data and storing it. It also has a lot of features, but not equivalent to Terraform. Vault. And so now let's come to about HashiCorp Vault. What actually HashiCorp Vault is. So HashiCorp Vault is an identity-based secrets and encryption management system. A secret is anything, as I told, a secret is anything that we want to store in encrypted form and no one is going to access it. So Hashicorp Vault supports your UI access, CLI access, HTTP API access, and other one that I did not mention, that HTTP, they also support SDKs in different languages. I would say not in some languages, but in a long list of many languages. And you can host your Hashicorp Vault at your own clusters, in your own instance, in your own machine. That would be called self-hosted. And you can also put it at Hashicorp Cloud. So Hashicorp has their own offerings as Hashicorp Cloud, wherein they offer multiple of their own services and tools. And your Vault is one of them. And there is not much difference between both of those. So if you want to migrate between those, they're completely similar. It's actually the same binary between shared between both. It's just that some features would be extra in your self-hosted, and some would be extra in your cloud. So we will look at that list, that which services are extra in your self-hosted and what extra services are available to you in the cloud. So moving on to next thing. So how does Vault work? Let's understand this first. So there would be 4 phases. First of all, what's authenticate? So let me say there is a restaurant and I'm going inside. So for me to enter, I need to give some kind of identification. So that's what authentication means. I'm going to give my ID card. Then in the validation process, what will happen is they will verify it and authorize me, not authorize, actually authenticate and validate me to go in. That okay, you are Ashish Kumar and you can go in. Now next thing is, in restaurant, let's say there are 3 tiers of tables. Not everyone is authorized to go into the private area. So I should have the actual access to the private area. That is what authorization is, what you can access after being authenticated. And once you're authorized, you can access your stuff. That's how Vault works. So as I told you previously, you can go to your you can access your secrets via CLI, via SDK, via HTTP endpoint. There are some other methods, like in Kubernetes there is a water injector, so that also infinitely leverages Vault API itself only. Moving on, so what are the use cases of HashiCorp Vault? So first of all, storing secrets. Of course, it's a secret management tool, so it would be storing secrets. So as I mentioned, 2 types of secrets: static secrets and dynamic secrets. So static secrets could be something like let's say I'm going to store my AWS password and I'm not going to change it for 3 months. I have a lifecycle policy, so I store that over there. And then there are dynamic, so you can have this in the dynamic form also. Let's say I have an application who needs AWS access, access credential access to do something on my AWS account, but it's not on AWS actually, so I cannot use IAM role and stuff. For that I need to go through a longer process. So what I will do is I will create a dynamic secret for AWS engine itself. So Vault supports a lot of secret engines. AWS is one of them, your Kubernetes is one of them, your key value pair is one of them. So in that, what I will do is I will set up my AWS secret engine in such a way, so every time someone wants to access it, it will have a lease time. Your secret will be dynamically generated, updated on your AWS account also. Use, let's say I put a lease time of 1 day. After 1 day, that key will expire and it will be regenerated next time the application tries to call it. So in this way, your keys are being regularly rotated, so it increases your security level. Next is your data encryption. So this Hashicorp Vault brings encryption as a service with itself, so that now you don't need to manage a different infrastructure for a key management. Like let's say in AWS, when you need to do, there are 2 infrastructure. When you want to store your secrets, you store it in Secrets Manager. For managing your key infrastructure, you actually use KMS, Key Management Service from AWS. So over here, you can put them in a single bucket and do both of them at one place. That is what Vault helps you do. Then as I said, identity-based access. So over here, we will be following least privilege access for everyone. And for that, we will be using 2 things, ACL policies, access control list policies, and your roles. And the combined thing of this would be known as role-based access control, is what we will be doing. And this is like when you are at your team is small, you can manually manage it. But when your team grows, you need to have this very rigorously built, because you don't want let's say an intern messing up with your production secrets. If they do that, your whole production workload can come down. So that is why RBAC is very important for us. Then moving on to key management. So the Vault Key Management Secrets Engine provides a consistent workflow for distribution and lifecycle management of cloud provider keys. So lifecycle management, as I told you, it has a concept of lease time and everything. So in that, you can set up how much time, how longer a secret should exist or a key should exist. Similarly, in the distribution format also, it would help us. And we can not only use the Vault's inbuilt key management system, but we can also leverage, let's say I want to connect unseal my Vault using AWS KMS, or let's say a Google key management service. I can do that as well. So it is quite flexible with other secret operator also. So now moving on to why Vault and why not to choose Vault. So first of all, it has a comprehensive feature set. Like by the time it has grown, it provides ample of features like secure your storing your secrets very securely, providing you fine-grained access, dynamic secret generation, leasing and revocation for life cycle management, audit logging, which is very important. You need to know who accessed which key in case something goes wrong. Cloud integration. Even if you launch your Vault on Hashicorp Cloud, it can be your VPCs can be peered across. Let's say you're hosting on AWS on HCP, Hashicorp Cloud HPC. So you can peer your VPCs and then you can privately access them. So it has a lot of options in doing that also. Flexibility. In case of flexibility, first flexibility would be, let's say I want to switch between on cloud and on premises of Hashicorp Vault. It allows me to do so, and its integration with a lot of other secret management engines allows us to migrate across secret engines very easily. So that is how it does. From security point of view, it has ample security feature sets, including encryption at rest, encryption in transit, access controls, as we discussed. So some of these points you would think are being repeated, but these are all the benefits of using Hashicorp Vault. And community and support is a very important thing nowadays in DevOps, because you don't get support of all the tools very easily. Like if you want to go to Stack Overflow, you don't get the answer. So Hashicorp Vault has quite a large community, and you have any questions, you can go to they have their own forum as well. You can just post a question over there and you get answered very quickly. So that's a very good point over there. Being open source tool, you know what you're getting into. You have a free option, you have a paid option, depending on your requirements, you can use that. And having a robust market presence, yeah, it's easy to use it. And let's say integrate, if you are going to integrate some with some other applications or other things, it gets easier for you to work on it. Why not? Complexity, as I told you, it has grown with a comprehensive feature set. Being a pro, it also is a con. Like for someone being a starter, it becomes difficult for them to, like, Vault CLI is one of those things which I am not very confident about, because what happens is I have been using it for quite some time, but it has a steep learning curve according to me. So the feature sets Vault is providing, at a level, it has become even complex. So you need to know every basic point before you get into deploying this. Otherwise, you could go a very wrong path. Cost. So cost is also a thing. Cost, if you are hosting, let's say on Hashicorp Cloud, if you go, they give you flat pricing on what would be your cost. And in production workload, managing your own secrets management system can be quite hefty, because you need to take care of disaster recovery, you need to take care of high availability, you need to take care of version upgrades and everything. So running at scale could be a thing. And performance, I would specifically say that this would be in case of hosting self-hosted, because on cloud, Hashicorp Cloud would scale it out for you according to whatever numbers you mentioned. But it can also have a limitation. Let's say suddenly your API calls to Vault increases suddenly, so then it could be an issue. So that is another con. But these are not very hard cons, but you need to keep that in mind. And in the end, every time whenever you're choosing a tool, it comes to your organizational requirements. It's not like if this tool has this feature, then I need to only go for this. But you should make sure that maximum of your requirements are being fulfilled by the feature sets of that tool. Only then choose it. And a few pointers I missed over up there. Let me just go back and finish up it over here. So when I was working about how does it work when we are going on authentication things, I would still repeat them in the workshop part, but let me just give a brief about it. So when you want to authenticate, it has ample of options over there as well. Like you can do root token, of course, is always the option. Like AWS root account, you have your root password and you log in, but not the best idea. And when you want to delegate access to other users, you can use OIDC, you can create identities, you can use username, password, you can use GitHub authentication. There are ample of options over there. These are like 4 or 5 I just named them that came at the top of my mind. And about the documentation, they have quite a good documentation. I am not going to cover everything because there were a lot of internals and concepts over there about how Hashicorp Cloud manages high availability, integrated storage, and everything. And then moving on to concepts about how there you seal your cluster, unseal your cluster, how operators work, how namespacing works. There are a lot of points. So for that, they have a very fine-grained and very good documentation over that. If you read that, it would help you a lot. And now we would be going ahead with the difference between hosted and self-managed cluster. So as I told you, this is a table I have picked from their documentation itself. This is not my own table. So if you see, most of the features are over there. The basic features that you require are available in both of the offerings, your self-managed and your HCP Vault. This is the Hashicorp Cloud platform Vault. So basic features are available in both of them. But now you see, if you see these last 4 options, when you're managing your own Hashicorp Vault, version updates become an issue. Not an issue, but it's slightly tricky. Over here, Hashicorp Cloud would be responsible for doing it, and it could help you go without downtime. Let's say for audit logging. Over here, Hashicorp Cloud is managing it for you. Over there, like if you are going to self-manage it, you will have to, let's say you are hosting it somewhere, then you will have to route. It's not difficult, you can do it, but it's on you that you route your logs to, let's say OpenSearch or let's say CloudWatch or Datadog. It's up to you. Managing its metrics, snapshot and restore, you can do it on self-managed. It's just that it's easier on Hashicorp Cloud. These are some advanced features. I can give you a hint about those. So disaster recovery, as you all know, if something goes down, HCP Vault is not going to be able to help you at that time. So if you have a self-managed, you can do it very easily. Sentinel is something you put on Sentinel policies on your secrets to make sure that your secrets are passing certain checks and criteria. Let's say I have a password policy, so Sentinel could help me enforce that password policy, that my password should be 6 or 7 characters. It should be a mixture of combination of uppercase characters, lowercase characters, special characters, etc. So we need to keep that in mind. And these are some other feature sets that I'm not going to discuss in detail because these go slightly at an advanced level. And moving on to, now we are going to start with our workshop actually. So let's understand what are the prerequisites first. So first of all, Terraform is not a prerequisite for using Hashicorp Vault, but for this workshop, because how I have installed and set up everything, I will be giving you a brief, because EKS clusters and everything I am not going to create in front of you, because that would take 20 minutes in itself. So I've already created them and prepared 2 EKS clusters for me. AWS CLI, because EKS is a part of AWS. kubectx Kubens is something it's up to you if you want to use it. It just makes your life easy if you are using across namespaces and across multiple clusters. So it helps you manage multiple Kubernetes contexts and Kubernetes namespaces. EKS is something that also is very much compatible with AWS EKS. It makes it easy to set up a lot of things on EKS clusters. Like if you want to set up a service account linked to an IAM role, it's easier to do with this command rather than creating everything manually and linking them up, adding on annotations. VS Code, the co-editor I love. So it has a lot of features. I'm not going to list them all, but yeah, this is the editor I'm going to use. Helm, because we are going to install our Vault with Helm charts. We can do it with them kubectl manifest and everything, but Helm charts is the one I would prefer because it's easier to manage, understand, and deploy. And then on the EKS cluster that I've created, I've already installed these 2 add-ons also. So the load balancer controller would actually help me, I would say, make my Vault public or private, or like through a load balancer, AWS load balancer, so that I can access it from outside the cluster, let's say from my private network or from the public network. And external DNS add-on would help me put a DNS name to it, so that I don't need to go through that long DNS name that AWS provides. HCP account, this is because I wanted to just show you how hosted version works. And Vault CLI, because a lot of things doing from UI is more difficult than doing from CLI. So Vault CLI for that. I would also be showing how to add and do stuff on that. So now we will start with the workshop. So first, let me show you a few things. Just give me 1 minute. Okay. Is my code part visible? Okay,
Yes,
great.
now it is visible.
So let me first show you what I have already.
Uh, just yeah, it is just yes. Now it is very well visible.
Okay.
I guess you can reduce the left hand side. That is the file. Yeah,
Okay.
yeah.
Sure.
Just
So
yes. This will give more.
okay,
Yeah.
great. So it's good now, right?
Yes, perfect.
Okay, great. So now I will tell you what I have already set up. That would take a lot of time. So let's start with the first part of Terraform. This is a folder by the name of pre-EKS. So what this does is this sets up a few things that I need to configure before EKS. So first of all is your VPC, where my EKS cluster would lie. So let me just do one thing. Open this up parallelly so I can show you what I have created as well. So a VPC with private and public subnets, and with these tags are very important if you want to use AWS load balancer controller, ingress controller thing add-on, so that it knows which subnets to catch for your load balancer. So over here, if you see the VPC is ready, your subnets are ready over here. So the ones that you see with this slightly different tag. Then if you see at the security groups, I've also created security groups already. So the vault default, the intra VPC. So I will tell you why this intra VPC subnet is very important, because without this, if these rules do not exist and if the communications do not happen, you will face a certain kind of issue that you will not be able to resolve. You will not find any errors in any of the logs, even if you go through all the vault logs and everything. You will keep your head scratching. Why is it happening? Why is my vault not working? And networking is a very important part of it. Nothing is failing, but nothing is working. That is a scenario when you without this rule. Then I have a NAT gateway for my NAT gateways, not NAT gateway for my private subnets. Then I have internet gateways also. So that's what this VPC does. Then over here I create a security group for my SSH and for my intra VPC communication. Then I also create an IAM role, which we are not going to, which I have not used, but we can definitely use for my. I am using a Bastion machine, so currently I connect it with SSH because I have also configured SSH connection. But over here, if you see, these are your policies for that, so that my cluster has my instance has the administrator access to my AWS account, and it can be accessed using the SSM connection. Over here, I create my EC2 machine, wherein I do not install everything because I do not have the script ready for that. So I installed my AWS CLI over here, I installed my Terraform over here, and install rest of the things manually later on. I will provide the links later on when I provide the documentation to Dheeraj. I will be providing everything over to him, and he can upload it over there. And this is my EC2 instance, a T3 medium size 20 GB GP3 volume. That's all. And now what we do is we go ahead and we create our clusters, two clusters. They are very similar, nothing different, just the names are different. I just wanted to do it because I wanted to show you a very specific scenario, that is accessing having a cluster, a vault on a cluster 1 and accessing it from cluster 2, because in actual production environments, your vault and your production workload will not be on the same cluster. There's a dedicated cluster for a few things. So vault has a dedicated cluster where vault is actually installed. Otherwise you keep it on, let's say, Hashicorp Cloud itself. So that is why I've created two clusters over here. And yeah, this is what is ready on this part. And let me also show you one thing. So this logs out. So just give me 1 minute, let me log into this. Okay, so over here is the vault cluster from Hashicorp Cloud, which I've created already. So to create this, before this, we create an HVN, a Hashicorp Virtual Network, which is a very important part. So let it just load. It's slightly slow. Sorry for that. So over here, what happens is I am going to create a network on AWS itself or Azure. We have two offerings right now, so that we can connect it privately to a network. We can do that cross cloud also using transit gateways and everything, but it's easier if it's on the same cloud. So I choose a region wherever I need to connect, because VPC is a regional resource. So for peering, if you want to do that, like you can do cross region and cross account peering also, but you can also keep it in the same region. Make sure if you're going to use peering or transit gateway, the CIDR blocks are different, because the VPCs with same CIDR blocks cannot be peered, because they will have a clash of which private IP to assign and to whom. So this is the basic thing required for creating a Vault cluster. So moving on to Vault. Okay, so if you see, I have already created a Vault. I will be showing you this, but let me also show you when you create a new cluster, what actually happens. So when you sign up for Hashicorp Cloud, I think they give you $50 of free credits, which you can leverage to try these things, which I'm also using right now. So as I told you, you have multiple Vault tiers. Development, this is the cheapest one. You have starter, you have a standard, and as you increase this, your price would change over here. So let's say I'm not into development mode right now. Let's say I have a company grown up to a standard size. So if I see that, it's $1,300 per month if you are going to use Hashicorp Cloud Vault. So just make sure that you don't use starter, just use the development one if you are trying things. And over it, when you choose, let's say starter, you also so I don't think they are having the offering. Yeah, so they are having the offering over there. So according to your use case, you can also choose your machines, so that okay, I'm going to have 1,000 API access per second or 2,000. So according to that, you can decide how much size you want to get provision. And you can choose your virtual network over here. You can also have the Azure virtual network over here and connect to it. Public, private. So this would give you a public endpoint. This would give you a private endpoint. This can be accessed from anywhere. So which I have currently set up because I've not peered VPCs and everything. So for the private, I would have to do that. So I'm going to show you this one actually. And any cluster that is having public access is also having private access. So both is also possible. No issue about that. This is the unique name that you provide to your Vault. And they have a few templates that they already provide, like if you have a certain requirement, but we are not going to use any of these because I wanted to show you how Vault works from scratch. So that is the reason I'm not going to use any of these. So I already have a cluster ready with a complete basic template. So let me show you what happens when you create a Vault. So when your Vault comes up ready, it shows some basic information on the left side, like what kind of is it, what small, when did you create it, is it highly available and stuff. And on the right side, you have a few action items. So when you need to access your web UI, when you click on public, it would, so this would actually copy your public and private URLs. And if you click over here, it will directly open it for you. So if I try to open private, it will not work. It will actually lead me to this. First peer it and then connect it. So because I'm not enabled private access. And when I click on a public one, I get the Vault page because I have already logged in. That is why you are seeing this page. Let me sign it out for you. And then you will see something like this. Namespaces, because we are using the default namespace, and admin is a default namespace that we get. And as I said, we have multiple authentication methods, which I will come back in a minute. So let me also tell you about a few things. So they also lead you to a tutorial of what kind of secret do you want to use. They have some usage values over here, that how many clients are being connected. So this is available internally also on the clusters. Previously it was not. It is quite a recent feature. So I'll be showing you this as well. Then how many entity tokens you have, how many non-entity tokens you have, and everything. Over here, it's just links to documentation, so that if you have any use case out of this, you can use that. Otherwise, you can go to Hashicorp documentation itself. It has a wide list of around 22, 23 possible scenarios, which are very commonly used, like having it on EKS cluster or accessing it with Hashicorp console and other variable options. And these two are very important things. So this is over here, I generate admin tokens. I don't want all my admin tokens to go away. I just click on the revoke admin token and all the tokens will be revoked, which I'm not going to do currently. And in case of emergency, this is like sealing your data. So what would happen is no one will be able to access your data, and neither will they able to write it, read it. So you can just click on API lock. This is like sealing your vault. This is when you create your own self-managed vault, you get a vault actually like this in a sealed state. So you can your storage is not actually initialized to write anything. So this is a lock level over on it. and you can come back over here and unseal it as well. So let me just generate a token and copy it. So I have already copied the token. This is the page. As I told you, there's a long list of methods of how we can authenticate: token, username, password. I can create identity list. Then LDAP methods, Okta, JWT tokens, OIDC method. Like I have a Microsoft Azure directory, I can just connect it to my OIDC or AWS SSO, and I do not have to reconfigure everything, all the identities again. They can just come log in using that. And then we have Radius, and we can also connect using our GitHub if it is configured. These are to be configured. These do not, any of these do not work by default. You need to configure all of them. Token is the only one that works. So I copy paste my token over here, and voila, we come into our homepage. So if you see over here currently, by default you will get this cubbyhole. Either you create it over here, or even in the self-hosted scenario, or you always get the cubbyhole secret. So just keep that in mind. Now let's go through this UI slightly first. 90% of the things over here would be similar on the UI, would be similar to what you will see on the self-hosted one. So I will only go once over here, and a few differences I will tell you on the self-hosted vault also. So over here, if you look at the secrets, so this is the secrets page. I was thinking on it. So this is the default page that you load into. Access. So setting up access. Auth methods, as I told you, we need to configure all the auth methods that we want. Let's say I want to set up multiple, I can do that multiple also. I want Kubernetes access, I want TLS certificate access, I want OIDC access, I want Okta access. I can do any of them I want. I will be showing you Kubernetes access when we will be doing multi-cluster vault access thing. And we go back to again to access page. We can set up multi-factor authentication for our users. We can have entities. So these entities are actually identities. Let's say users. So this is the default entity we get, but we can create multiple entities and give them access. You can group the entities over here and use them. Leases. For this, you need to have a lease ID to look up. So lease IDs are basically related to your TTL. Lifecycle management of your secrets. Specifically, I would say especially we use them with dynamic secrets, namespaces. So now you see namespaces everywhere. It's similar to having multiple users having isolated environments in a single vault. So we want my development team and my development A team, product A team and product B team to have completely isolated environments. I can do that using namespaces. So A team cannot view B team and B team cannot view A team, which is very important scenario. Then we have the OIDC providers. If I want to link it to, let's say, Microsoft AD and everything, then it will become a, like, if I want to log in using AWS SSO, I just click on the SSO login and automatically get authenticated over here also. So that was all about the access things. Now moving on to policies. Just creating users and entities won't work for us. If someone even authenticates, if he does not have authorization, he cannot access anything. Actually, authentication is not the only thing. So to set up complete rollback access control, we need the ACL policies. So if you look at, let's say, these are the default policies that we get. So this is like the super user policy, like AWS administrator access, having access to everything from root to everything, like secrets. So by this star over here, we put paths. So these paths can be like secret/secret name if you want to set up secret access. Or let's say I want to set up some system access, so it will become sys/ and the following path. So if you do sys/star, then he or she will have all the system configuration access. So that is how we write policies. You can just edit policy, create over here. If you want to download the policy, you can do that. So probably I am having another policy in my self-hosted cluster. I will be showing you that. So this is the default policy that they give you. This is not the full access policy, but the default policy that they give. And if you see, I told you there are different types of paths: authentication paths, and then system paths, and then identity paths. Then you would show secrets paths. So there are multiple variations over there. And if you put a star over here, then it means all. And over here, you cannot put a star. You need to actually put these values, what capabilities you want your role to have, like create, read, update, delete, list. It's up to you. If you want, you can also deny. So deny is also one of the options that you want to specifically deny access to something. And then we have some additional tools for this. Let's say this would be one of the most commonly used tool. So for this, usually what people do is they just Google base 64 encode decode, and we have a very known website with a green UI. over where we decode and code. Now you don't need to go outside this. You just need to put in your input value. You need to choose your algorithm. You choose your output format, and you get your hashed output. And you can encode and decode both over here. And similar to wrapping your data. So let me just show you an example. Let's say I need to wrap my data. So I will be showing you two things actually about this. So hello world, and let's say if you want to put a TTL, like after 30 minutes, this wrap data will be obsolete. It won't be usable. So you can even put a TTL on it. So let me just put on it because I need to show you something. I wrap the data and I get a wrap token. And when I look up, it will give me not the data, but it will give me all the metadata about it, like when was it created, what's its path, or when does it expire, what is the time to live for it, and expiration date in exact time, and creation date and time in exact values. And what the thing would happen is, once I unwrap it, I would get all the unwrapped data over here. I would get the unwrapped details, but now I go up and over here, it won't work, because once you unwrap it, it's gone. Your things have been unwrapped. And if you want to rewrap, you can get your token again, and you can put a fresh TTL and rewrap it again over here. So I already unwrapped it, so I do not have that token, so it's gone. So that's about this. Client counter is something new. So this is something for a billing period. If you want to know how many users have accessed your vault, so this will only be, let's say I access vault every day, but I will be only counted once across a billing time, so that I can track, but during this billing time, how many unique clients did actually connect to my vault. So this is something new that I have also recently seen. And over here you get a slightly detailed form of that, like who accessed which namespace and everything. And admin namespace is over here, you get by the default in the cloud one, because over here you do not have all the access. Cloud Vault does not give you the bare base access of everything. That is why they give you an admin namespace and give whatever they need to. It's just like hosted Kubernetes clusters. You do not get access to kubeadm and stuff, so you don't break your cluster. It's something similar over here as well. And over here you get Vault CLI. You can just run in your Vault commands directly over here, but it does not support like according to me, but what I have tested, not all the Vault commands work over here. So keep that in mind. If you want to use full-fledged Vault, install Vault CLI and then use that. And over here you can just have a restart guide. If you want to set a multi-factor authentication, if you want to copy your token with which you logged in, you can have that. Now let me just show you about how to access this from CLI. So let's jump back over here and let me clear this. So no, not this one. So this is my home machine, base machine VS Code. It's not connected to my Bastion host. So let me just pull that down, and then I will show you how things actually have worked, because my Kubernetes clusters are privately accessible. It's endpoint, so I cannot access it from this machine. Sorry. So let me just pull this down, and let's go to next vault. And let's say we are going to ignore this, and let's first start with this. And so let's understand, if I need to access a Hashicorp Vault from CLI, what things I need to access. For Hashicorp Cloud Vault, you need actually three things for minimum. Your vault address, that is your vault endpoint. Then your vault token. It could be your client token you generate from your OIDC or your from access, or you can have your root token. We will be using root token for the time being. Then we have the vault namespace. We have not created any extra namespace, so we are going to use the admin namespace that they provide. So let me just quickly set this up. Export vault addr equals to, and I go back over here, and I just told you, if you want to copy, if you want to open this, if you want to copy, then this. You come back over here, you paste it, export vault addr. So your vault addr is ready. Then you do vault underscore token. Not a good idea to show your token in public, but what can I do? Let me just copy this token, paste it over here, and then I need to do this namespace equal to admin. And now what you need to do is you need to do vault login. And but just keep that in mind, you will have to re-give the token, because this token finally gets saved somewhere else also. So if you see vault token environment variable, it will automatically update it over here also if you do not do this. But I have a habit of doing it, so I did it. And this vault token is actually also stored at one place. So in your home directory, you will find a file named by this once you do Vault login, where your Vault token actual value will be stored. So you will have that also. And now once we have logged into Vault, uh, I'm not going to show anything extra over here because I'm not going. Finally, in our self-hosted cluster, we will be creating secrets. We'll be creating logins from CLI also. So I will be showing you the actual practical implementation over there. This is how we can connect to our thing. Now let's jump back to something, installing our self-hosted Vault. This is a very interesting, pretty interesting part. So let's start with that. So for that, we, as I told you, we are going to use Helm repos. So for that, we already have. So let me show you that first. So if you just go to Google and you do Helm chart Vault, just make sure Hashicorp Vault, because there is a third party offering as well. So Artifact Hub, this is a very good page that I like, repository for all the Vault pages. And over here, you get a brief detail about how to use it and stuff, and how you can customize it. You can find the value in the templates if you want, like the detailed thing. If you want to see over here, just come over here, and this will also tell you what kind of variables are possible, like how can you configure your Vault in different ways, and these are the kind of values that are available to you. Like we will be using this in our secondary cluster, because we are not going to host a cluster over there, a Vault over there. We are just going to use injector so that I can access an external cluster and get secrets and put it in my pods over there. So we will be using this at some time. And the good thing about it is like this page is in the default value, it tells you like the default value for those all the variables, and it also gives you a brief like what that variable is actually responsible for. So it's easier for you to understand and set up. So I already have prepared a command, a very short one, and we are not going to use everything in this because we are just setting up a basic Vault. So for this, let's just jump back to our this command line. So for that, you need to first add your uh, Helm repo before we install it. So let me just copy paste the commands because I'm not going to write down the long commands. So if you see this, so this would be your first command, and you do Helm repo add Hashicorp and then the path where it is being actually hosted, and you add it. I have already added it, so it just exists. It gives me a not a warning. It just gives me a message that it already exists, and it will be skipping the further thing. And if you want to make sure that your Vault has been added, you can run a simple command, like if your chart, because this is a repository, inside this your charts are over there. So I do this and I see that okay, there is a Vault chart available for me. The chart version is this, and the application version of the Vault would be 1.13.1. And then now we will be installing it. So first let me make sure I'm on the right cluster. So I'm on the wrong cluster right now. If I would have installed it, then what would have happened? We would have installed our primary, hosted our Vault on the secondary cluster, which we don't want. We want to host it on this cluster. So we quickly swap our cluster, and now we are on the main cluster. And so we see we have some pods already running, like a load balancer controller. These are some core pods responsible for networking, managing your node connections to your control plane, your EBS CSI controller. This is a very important one. This is also an add-on that I missed previously, because we are not going to specify any backend for our self-hosted Vault. So it will by default take up EBS volume. If you see in the layman's term, your actual hard disk for storing its data. So in this case, it will, using this EBS CSI controller, it will actually request a EBS volume from your AWS, and create a persistent volume claim, and connect it to the pod. In layman terms, a pen drive that will be connected to your pod, and you can access, you can store your data and access your data from there. And these EBS volumes are configured in such a way they are retained. Like even if your pod goes down for some time and it restarts for some reason, for let's say because of version upgrade, your PVCs will still persist, because they in their name they have persistent volumes. So they will persist, and when your new pods come up, because they are stateless, it will automatically link to your volume, and you will have your data again. You will not lose any data in those scenarios. So now we are going to set up, install a standalone cluster. We can have multi-node cluster also for Hashicorp Vault, which I'm not going to do for that, because we will have to create connections and everything. That would take some time. So let me just quickly install a standalone cluster. I already have the command ready. So you just run this command, and I have enabled standalone true, nothing else. And because of this, it will take a few other values, all the default values that you saw on that Helm page, the artifact hub. It will take those values, and when we do it, it will just take a few seconds, and yeah, it's ready. If you want to see something more, like, let me just quickly this over here. Yeah. So okay. So if you see over here, if you want to see what your status is, this is just a Helm command, and it will tell you, okay, it has been deployed in your kube CCPM system namespace. If this is your first revision, this is like versioning. If I am upgrading my Helm chart, it will keep a revision of those installations, so that in future if you want to track, you can track that. And if you want to see what manifest was used, because by default, any installation that you want to do, Kubernetes manages it using manifest. Underlying, even below Helm, you are actually using Kubernetes manifests only. So like, if you did not want to use your Helm, then you would have used this long file that you would have to edit yourself manually, a very long procedure that you do not want to go through. So you see, all it has taken all the values by default, like the cluster address, its telemetry. It's disabled right now. So if you want to set up like automatic unsealing, I will tell you what automatic unsealing is when I tell you about how we are going to set up our thing. If you I want to set up injector, so this injector is also something that we are going to use in the next steps, so that our secrets can be injected into our pods. Then your roles and everything, then your service for internal access, for external access. So we will be, so by default, because this is a standalone cluster, I could not directly expose it through ingress. So for that, I have a separate manifest file written, which I will be now deploying, which will take a few seconds to deploy, and we will be ready for that. So these are all the services. If you want to look at this, you can go through it. You can understand how it is actually being deployed. The other option is, if you don't want to see over here, we want to see before installing, you can just come up over here. You can go to your templates, and you can see like what happens under which resource and how are they created. Anything like this is the a pre-refined version of that with actual variables, and over there you have it with variable values. So that's the only difference between the templates. And now we go back over here, and let me just quickly create my let's first see about something, what our vault status is. So let me first see. It told us that we are on kube system namespace. It's installed in kube system namespace. So let's see on which kube's namespace we are. So we are already on kube system. If you want, you can just change it kubens, and you can put in the name. This is because I have installed kubectx kubens add-on plugin. That is why I'm able to do it. Otherwise, you will have to use a long command of kubectl, which is like repeating it is very irritating sometimes. So that is why I use this tool. And now if I tell you, I see what pods are running, you would see some pods are added. So these two pods are already added. This is already in running state. It does not care about what's happening outside. This is our actually vault, which we will be linking to and using it. Just a minute, I need to have some water. So this is the vault pod that we will be actually connecting to and accessing all our stuff. Now if you see, all her pods are in 1 of 1 or 3 or 3, like they're completely ready. These pods are running, but these are not in ready state. Why are they not in ready state? Let me just show you why. If you see this kubectl exec, so this is something like I would not say SSH, but it's like getting the shell out of that pod and executing some command inside that pod. That is what I'm going to do right now. So I put the pod name, and then I do vault status. This is the command that I am going to run. And if you see over here now, as I told you, the pod by default does not come initialized, and it is sealed. So what does this mean? So by this, what by what this is trying to tell us is that our storage, our backend storage, is not yet initialized and ready to receive data and give back data. So you need to first initialize it, and only after that you will be able to use it. So first we will initialize our vault, and then we will set up our ingress controller for this. And now if you see, and yeah, also as I told you, by default it is taking EBS. If you want to use, you can use EFS, you can use S3, you can use other persistent better options available outside if you want. It's completely in control. Like in the config file, in the config map file, you can clearly mention that I want to use S3 backend. I will give the S3 backend access method, like I'm going to access it by IAM role, I'm going to access it by token, I'm going to access it by keys, and you'll be able to connect to S3, and your vault will be then using S3 as the backend. And now I'm going to run the command uh, so that our storage becomes ready, our vault becomes initialized, it becomes unsealed, and we are going able to access it. So now I already have this long command ready. So over there, if you see, first I will tell you what this command is actually doing. So I'm again executing a command inside that pod itself. Vault operator is one of those commands that is used to initialize your vault. Key shares one, so this will actually create the root token for me. And key threshold, like when you have to unseal your vault, how many keys do you want to be generated? If I do it 3, it will generate 3. If I set it 1, it will generate only 1. So, and it will also save the output of it in my this file, cluster keys JSON. I press enter, and once the command executes, it's already there. And when I do this, if you see over here, it only created one unseal key. It created the root token, and we are good to go. So now if you see, it's not yet completely ready to be used. So for that, we it's now if you see, run that again command, same command again, you might see some difference. So over here, it's already initialized, but it's also sealed. Previously, if you see, it was not initialized and it was sealed. So we need to make this true and we need to make this false in order to access it completely. So right now this has become true. That means our storage is ready to receive and give back some information. So now we are going to do our next step. So if you see this key, it has underscore B64. By underscore B64, it is already base 64 encoded. So we will have to decode it. So for that, what I will do is I will run another command that I already have. And in this, it will, what it will do is it will uh, uh, show the data. So what this command does is it will display your data like I did over here, cat, and the data came up. Out of it, what I will do is I will run some iteration over it. I will use the JQ command line tool and parse this data, because if you see, this is a JSON data and I can parse it in the JSON format. Out of it, I will only pick the unsealed keys base 64 value. Over by default, it will pick all the values. Since we only have one value, it will pick this only one value, and it will also store it over in there. And now what we will do is we will run the operator unseal command. And over here, if you see, it will unseal my vault. Now if you see, it has become true and it has become false. So now our vault is completely ready to be used. So now if I show you one of the old commands, get pods, and now over here, this pod is 1 of 1. It's completely running and ready. So now our vault is ready, but it's not yet accessible, because if I see this service, we already have two services ready that the chat has created, our internal service and our normal vault service, but we cannot access it directly since we are outside the private network. Neither we are in, and these are already cluster IPs. So even if you were in the VPC, you will still not be able to access it. For this, you need to be on the node, not on the node, actually inside the pod, because these pods are intercommunicable only inside the cluster itself. And I cannot launch my web browser inside it. So I need to have it outside. So I already have a file ready. So let me just show you vault ingress file. So over here, if you see, I've created a file over here. So what it will do is it will create, this is a health check by 307, because by default it's not accessible. So I just configured it accordingly. It will be HTTPS link. So everything is included in transit as well. I'm not going to use HTTP endpoint. I already have a domain with me. So I'm creating a subdomain out of it. And for that, I'm using an ACM certificate, which I've already created. This will allow me to set up HTTPS connection, HTTPC load balancer, HTTPS load balancer on AWS. So let me just quickly run this command: kubectl apply -f workshop next 3 vault ingress.yaml, and this ingress is being created. Now if you do kubectl get ingress, so it is being created. Now if you look at, let me show you what is happening right now in the backend. So if you come to this load balancer page, and if you click on this, refresh this page, if you see, this is provisioning. So load balancer takes a few seconds to provision. So just give it 10 to 20 seconds and you should see it up. And also what has happened is something extra, another thing has happened. So this is not old record. So that is why you are seeing, I have it in the upsert format. So it does not delete the old ones. That is why you are seeing it over here. So what will happen over here right now is these values will also get updated, and to verify it. So what we will do is just give it a few seconds, and then we will see if our vault is up and running or not. So let's quickly go back to over here. So these are links.
So, Ashish, what I
Yeah.
would request is switching between different screens
Mhm.
and switching between different browser. If you take it slow, it might be helpful, because what I can see over here is sometimes it gets blurred when there is fast switching between multiple
Okay.
application or a browser.
Okay. No problem. I will keep that in mind. Thank you. So let's come back over here and just this is should be visible by now. If you go over here, sorry, load balancers, and if we refresh this page, let's wait for a few more seconds. Let's do this. And it's not ready. So it has updated my DNS over here. So if you see this, and let's say I do DNS propagator, and we quickly go to any of them, and I run this, and I do let's see what kind of entry it has made over here. So it has made an A-type entry. So we do a A-type entry and we do a search. So it should come up. Yeah. So it's already propagated across the world on all the DNSs. So we will be able to access it. Now we are just waiting for our load balancer to be ready. So yeah, it's already active. So now if I do this thing and make sure to add this, and it's sometimes it takes more time. So just give it a few more seconds. Let me just confirm a few things. Sometimes it takes more than a few seconds. So yeah, just let's wait and see the rules. So load balancer actually uses target groups which need to be healthy in order for us to access it. So it is. So yeah, so this part is done. And because I already had something other on my machine mapped, so the DSs have a TTL. They also have a in lifecycle management. So probably it's trying to link to the old one. That is why it's not able to open. Let's see quickly. Otherwise, what we will do is we will use in the time being we will use our let's see. No, it's not yet done. So what we will do is for now, since we know our load balancer is ready and our target groups are also healthy, let me just confirm that once. If you see our targets are healthy, so actually what is accessible. So what I will do for now is we will just leave it as it is, and we will just copy the DNS name out of it, and we will just go over here and paste it. And don't open HTTP, you will not be able to open it. So you need to go to HTTPS, accept this and continue. Not a good idea to do this. Actually, we need to access this, but this will take sometimes it takes a few minutes. Actually, this happens because I have been changing rapidly throughout the day, so that is why it is happening. So now it is asking for a token. So where do I get the token from? So we go back. So not this page, sorry, this page, and yeah. So over here, if I remember, this was the file it had. So if you remember, this is the vault token we have. So this is publicly accessible. If you want, you can go to that endpoint and access it also. Like if you do this, you will also be able to open the vault. No issues about that. So as I told you, you will see something very similar. So everything is there. If you see access is there, policies is there, tools is there. It also has an extra root policy which you do not get over there because uh, giving root access on your cloud hosted service would be a bad idea. They don't want you to break something, not only for yourself but for others also. This is something that different over here for this. So it tells you that if your vault is unsealed or unsealed format, and client count was already there on the cloud hosted also. So you can look at the set it up and see how many of people have accessed it. And you have the terminal option similarly, you have the copy token option similarly, and like rest of the tools are pretty much the same. So now we are ready with it. So let me see what we need to do next. So yeah, so our vault is ready. We are not yet going to uh, create secrets over here. Let me do one thing first. Let's go to our other cluster, and on the other cluster, let us first install injector, so that we will be so what the actual scenario would be, we will be hosting our secrets on cluster A, and we will be accessing it from cluster B. That's what usually happens. And it so what happens is when you do it in the same cluster, a lot of things are already being taken care of. Like intra-pod communication and your token reviews, everything is being internally managed by the help chart itself. But when you do it on two different clusters, it's not being managed. So you need to set it up. Otherwise, you get into certain issues that you don't not see the error anywhere, but you are actually facing an error. It's like things are working but not working. So not a good idea. We'll keep retrying it in every few seconds. Maybe it opens sometime. So what we will do is, let's go to the other page. And now we will just quickly clear this up. And we will do is kubectx, and we will switch our cluster. So now we are on our secondary cluster. So we are on secondary cluster. Just to make sure we do a kubectl, we are on default. Let's just do one thing: kubectl get pods -n. And if you see, there are no vault pods running over here. Okay, one thing I missed. So let me just quickly go back and show that to you first. kubectl get pods. So as I told you, it is going to use a persistent volume and persistent volume claim. So for this, if you do kubectl get pv, so this is the persistent volume that it is getting from AWS for 10 gigabyte of size. Read write reclaim policy would be delete. The status is bound because it is in use. It is a GP2 type of volume from AWS. It has been 15 minutes of age, and this is not being actually connected to your pod. From this, we then take out a PVC, persistent volume claim, and we use that. So we created that data vault 0, and this is being bound over there. The capacity 10 GB, so we are completely using this persistent volume. Access mode is read write only, and GP2 and 16 minutes. So this is something that I wanted to just quickly take through. Now we again going to switch our clusters, and so now we are on a different cluster. So now, as I showed you, we do not have any vault pods running. So we need to set up a few things over here. So I already have the command ready for setting up injector as well. So if I show you the command, this is the command. So what will happen is here is it will only install injector. It will not set up my vault cluster in any form. And since this URL is not ready yet, so I don't think it will be a safe bet for us to use it. Either we wait or this is the most that part I hate about. Let me just check later. It's ready. Actually, it should. I don't think so. So for now, what we will do is instead of using this, I'm not sure what's happening. It was working fine. Maybe in the end it starts working. So instead of using that, we will be using the this thing, because this is also persistent. It's not going to change in between. So for the time being we use, it will stay persistent, and so we are going to use this. And now this will only install the injector, and it will automatically know which external vault I need to connect to. It will not actually connect, but it will know. So if you do this, it will take a few seconds, and it is ready, and kubectl get pods, and the injector pod should be up and running. So let's wait for a few more seconds. It's already running. If you do kubectl logs and you run this, and if you look at it, so the books have been updated internally, your certs have been exchanged, and everything is ready, connection is built. Great. So it is listening on port 8080. So in internal, like listening is very important for this. So now we clear this up, and now what we need to do is, once we are done, we need to set up something by known as token review, because without this token review, it will not actually work. So for this, what will happen is, let me now tell you what we are going up to next. So there will be a pod on our cluster B. Cluster A is the primary cluster, cluster B is the secondary cluster. So on the secondary cluster, there will be a pod that is going to use a Kubernetes service account to authenticate into my vault, authorize itself after authentication, get the data, and put it inside the pod. So for that, we will need to configure a service account. In the recent versions of Kubernetes, they have removed automatic secret creation. So for that, you need to manually generate a long-term secret. That is why I'm creating a secret. You don't need to do anything. You just need to write this type thing, and it will automatically create a secret linked to this service account, which we can use later. And this service account should also have access to token reviews, token reviews API of the Kubernetes. So for that, I'm not going to create another role, another Kubernetes role. System auth delegator is capable enough. It has, like, this role already has the powers of token reviews. So we are straight up going to use this, and we are going to link it to a service account that we're creating. And then we will be, our authentication part would be ready, so that we can use it further. So let's just quickly apply it. Workshop 4 and review.yaml. I will also show you we will be looking at these tokens because we will have to configure this actually. So we are going to use it. And some part I will show you from the UI for configuration of Vault, and some part from the CLI, so that you get a taste of both, a bit of both, that okay, we can do things from both of them. Some things might not be possible from both, but yeah, most of a lot of things are. So now our Vault access service account is ready, our secret is ready, our cluster role binding is ready. So now what we are going to do is we are going to set up it on the over here. So now this is our Vault. So we need to set up an authentication so that not X person, the access Vault service account from my other cluster will come up over here, authenticate itself, get the data. So of course you need to configure over here. It's like creating an IAM user and giving out the credentials. So I go to access and I enable new method, and we have multiple authentication methods available. If you remember, I told you in the beginning that we will be using Kubernetes authentication method in the next phase. Over here, I'm not going to change the path. So this is the path is something like putting a name for authentication method. These are the method options if you want to understand. Like, we are not going to go in deep into it because it would become a long one then. So we are going to use the default service one. I'm not using any time to live TTLs, any lease times right now. We are not doing that. We are not enabling seal wrap. HMACing is on audit so that your keys do not get hashed. Otherwise, sometimes audits could fail if your audits are not configured for that. So we request to exclude those keys on audit. That's HMACing thing. So HMACing could be your hashing with salts. So something like that. So we are just going to create this. We are going to enable the method. So right now only our method is ready. It's not yet configured. Now is the configuration step. So for this, 3 things are important. The host, which cluster is going to come and access me. CA certificate, this is the method of you accessing the cluster. So when I am trying to access any cluster, so if you do this, so if I show you one file, so let's just do that. Not cache, config. If you see this, like these are the both cluster that I have configured, which I'm switching between. We set up context between them, and over here it is getting the token directly from there to authenticate and everything. So you do not see a lot of things. Like if it was your own cluster, then you would have also seen a Kubernetes CA certificate value when you set up your own cluster. We have generated this for this cluster also using that token itself. So let me just start doing it one by one. So first, to get your co-host name for any cluster, you just run this, and I think this would be the command. Cluster info. So it gives me, this is my control pin endpoint. So I'm going to just copy this, paste it quickly over here. Now I need the CA certificate. So for this, if you remember, I had created a secret, kubectl get secret. Okay, sorry. And this is the secret that we had created. Now it has 3 data points. So if you do a describe quickly, yeah, kubectl describe secret, access vault, and over here if you see, it has a token value, it has a namespace, and it has a CA-CRT. So this is your what we know as Kubernetes CA certificate. So what I will do is I will enter it as text because I'm not going to download it. It will be clear text so that you can also see what I'm copying. So I already have a command ready because I'm copying this. What you can do is you can copy it from here, go and manually decode it. For that, I already have a command ready. So what this would do is it would fetch it because it is in the, you can like this describe value, instead of using describe, you can get it in the YAML format also using JSON path. So using that, I already fetch the value of data.ca.crt by what this one, and then it is already in the encoded form. So we do a base64 decode. This is a CLI command, and I just copy this thing, and then copy it and paste it over here. So our CA certificate is ready, and now we need to have the token reviewer JWT. This would be the secret token. And over here, if you come back in the same one, uh, like I copied the CSCRT, instead of CSCRT, if you see over here, I do the token and I get the token decoded in the decoded format. So now I just quickly copy the token. So our after this, our authentication method would be ready, and we quickly save it. So I'm not going to test it right now if it's working or not. So now the thing is, our authentication method is ready. If I click on it, great. But only authentication method is not enough. If I authenticate to cluster, if someone authenticates to cluster, he or she needs to be also authorized to access something. So for that, we will create a role. Roles are responsible for that. So I create by this, and now we are going to ignore the alias. We are going to ignore the audience. If you want, you can do it using the JWT service account names. Which service accounts on your Kubernetes clusters would be allowed to access or would be authorized to do things that are written in the policy linked to this role. So my service account name is Access Vault. If you remember, in this file, we have created a service account by the name of Access Vault. And then we also need to mention in which namespaces would those service accounts be. So if you do this kubectl command, we are in the default namespace. So we will quickly copy and paste the namespace over here. Under the tokens, you can set up a few things over here, TTLs and everything. If you want to attach any default policy, if you want to generate, set up a period for, if you want to set up maximum uses of generated tokens. But the thing that we need to take care of is generated token policies. I'm already giving it a name over here. We will be writing, this is the policy name that will be linked to this role. You can add multiple, like all of these can be added in multiple numbers. So I just click on add, and I just click on add, and I can add extra ones. So Access Vault is a policy that I will be writing. And let's say I want to initiate a expiry time, so that the token that would be generated would be leased after 1 day. So for that, let's say I put 86,000. So my keyboard is slightly in a bad state. So this is actually 1 day. So after 1 day, your generated token would have to be again and again renewed. Will be renewed automatically. You will not have to do it, but this is the expiry time. It's not mandatory. I just did it because I just wanted to show you something. And token type, let's say I'm just going to use the default or service. Let's ignore it for now. If it does not work, then we will come back to it. And let's see if it is working or not. It's still not working. Something is wrong. I will have to check later on what I went wrong. Now our role is ready. And now what we need to set up is we need to write down this policy. So we go to Hashicorp policies, and we are not going to use the root policy. Not a good idea to give someone access to root policy. We are not going to use the default policy. We are going to write our own policy. I already have a policy written, so we will be using just that. So we will be using this name. And now if you go to the right, and I might be having it somewhere. Let's see if I have a policy written. Yeah, so I already had it written. So actually, this is like doing all slightly lower than root, but yeah, let's say I'm just let's keep it like this. So it's all. So this actually covers all of those, but I'm going to. So what will happen? One thing to keep in mind is, even although I allow everything on star, but because of this rule, your sys/star is in deny mode. So even after having open all, deny will take precedence over allow, and it will deny you sys access. Just keep that in mind. So deny overrides allow, and we create a policy. So our policy is ready, our authentication method is ready. So probably now if I want to access, I should be able to access. So what I will do now, let us first create a secret. So for that, what I need to do is, we will be doing this with the CLI. So let's come back over here, and again the same steps: vault ADDR and your vault token. So for that, let me just quickly copy it, and vault ADDR, let's do this, and we need to get the URL. So this is the thing, and Okay, and export Vault DDR. Then you don't need the namespace over here, so I would be removing that. I will not be setting that up. And I do this. Okay, my bad. And I need the token. So I can get the token from there, from that file. I can also use copy token over here. It also stores it, and it gets me the same token. It's not a different token that I used to log in. This is particularly very important. Let's say when I am going to using OIDC login over there, I have not logged in using a token. So just click over here and you click on copy token and you get your own token, which is being used for that session. And after this, now what we are going to do is Vault login again, and we just paste it again. It should be successfully authenticated. Sorry, something went bad. Let me. Okay, just because it's an HTTPS, I might have to change a few things. Got updated, but it's not updated. That is the strange part. Let me just do one thing quickly. Let's see if we are able to fix it, then we will continue with this one. Otherwise, I have some other way of doing this also, so we will switch back to that. Let's quickly delete or records, delete. Hmm. Let me see if I'm able to log in on my other device. The same. Wallet. Oh wait, this would be strange. HTTPS. So I'm able to actually access it on my phone. So this is something specific to this. Let me see if I switch browsers. Is it the same? Because the browser issue, sometimes it happens with that. So yeah. So what we will do is quickly do one thing. Um, so we will quickly uninstall the Vault chart from there, and we will update it using this. Just give me 1 minute. Sorry about the hiccup. I should have checked it earlier, but I did not. Vault. We might have to again reconfigure the authentication method. Sometimes it starts breaking, but if it does not, then we would be lucky enough. So we'll do this. And so now, instead of what we were doing was going to this put command. So now we will continue from over there only, but just do this log change. Their command. What? Wait, okay, no problem. We'll just do this. Yes, and get it from over here. And yeah, so now if I do Vault login, I hope it should work without any error. Yeah, so we are in it, so everything is working fine, hopefully. Not sure what's wrong with Firefox today. Sometimes it caches things, so probably that. So now what we will do is we will create a secret first. So one way is, uh, uh, so let me just close a few tabs first, otherwise we'll be stuck. So yeah, we were over here. So what we can do is we can come over here, we can create multiple types of secrets. Like this is what KV is. KV is a key value secret. Let's say I want a rotated SSH key dynamically generated. We can have this. We want a time-based OTP keys. We can have this. We can have Kubernetes secrets. We can have AWS access credential secrets. We can have AD secrets, like a lot of offerings. So if you want, let's say I want to create a KV key, I can come over here. I can create enable engine and then create it, which I'm not going to do right now. So we are going to use actually KV version 2. Keep that in mind. We are not going to use KV version 1. So for that, I already have a command ready. So let me just quickly copy and paste it. So what this command would do is it would create a, a secret by the name of internal engine, and we are using the engine name is KVV2. The name would be internal, and it would have been created. There would be no secret inside it, but it would be created. So if you see, internal is already created. This is a secret engine. This is not a secret yet. So if you click on it, nothing is inside it. No secrets in the backend. So this is the internal is your secret backend, actually, the secret engine that we are using. Now I'm going to create a secret. So this is a secret that I have. So let me just create that. So let me show you this command. So inside that, I will be creating a database folder directory, and there's that config, and under that you will be creating a JSON type of secret with the username this and password this. So if I click on it, it's already created. This is the secret path. And now if you look up over here, and if you again click on secrets, and let's go back internal. Now if you see, database is there. Inside database there is a config file. So this is your actual secret file. That was a folder, and inside this config you have your secrets as it is. I did not hash it, I did not do anything, and it is also in the JSON format, as I said. And this secrets are actually versioned, so I can create a new version of this secret, change something and save it. So let's say in future I do a mistake, I forget to add an E, I save it, and now I am stuck at this, so I do not want it. So I just go back and I go to version 1, and yeah, so this is being in use. I do not want, so let me go to version 2 and I quickly delete it. I just want to delete this version specifically. Yeah, so these two are also great options to look at before you do. So delete will actually put it in kind of a recycle bin, so you can get it back, fetch it back. Destroy would be like completely destroy. So this is like an S3 delete marker. When you enable versioning and you delete an S3 object, it gives it a delete marker. It does not removes it from your S3 bucket. You have to remove the delete marker to actually delete that object. So let's say I'm just going to destroy it completely right now because I do not need it. So our version 2 is gone. Strangely it got logged out. So let's just quickly go back and log in. Yeah, having it over here. Sign in, and if you see, version 2 is gone, hopefully. So version 1 should be already here. So yeah, okay. Now we have version 1 as it is. You do not see a third option. You do not see a spelling mistake. So version check. So now I need to show you how in phases this would happen. I will be creating a pod without any secret access. Then I will be giving it an access. Then I will be adding a pod to it. So a couple of important things over there also. So let me just quickly go back over here, and I have a file ready by the name of Nginx Vault. So over here, if you see this file, let's remove a lot of things from here. Let me see what I'll need to keep. Was this the one? Okay, so I have it over here. I can just quickly move it. So this is the wrong annotations. So we are going to create a deployment. Deployment will create my pods. Pods will have secret access. So important things to have secret access. Service account name by default. Default service account is used. So for this, I need to attach access vault because this is the service account I had created that is actually having access to my vault secrets. It can authenticate, it can authorize, it can get me the secrets. These are the annotations. Without this annotation, it will not know that the pods, the secrets need to be injected over here. So let me just first show you without this. So right now, there will be a service account name linked to it, but it will not have any secrets. How? I will show you. kubectl apply -f workshop 4 nginx -vault.yaml. It is ready, and if I do kubectl get pods, so you would see some differences when we go up. So right now there is only one of one ready, and just to confirm, I have slightly long command written. So this will get all the pods of app nginx type. So if you see at the label over here, this is the label matching. It will fetch it. It will get the name out of it, so that we check it through all of the pods by the name of nginx. And we are going to, because by default a vault folder, and inside that a secrets folder is created under which all your secrets are injected actually. So that is why when I run this right now, since we do not have any uh, secrets injection enabled, so this is not there, no such file or directory. And the other difference observation you could see right now over here, this is one of one, because the injector init pod did not run. Now I need to set that up. So what I will do quickly is I will just patch this deployment. So I will enable it. I will not completely enable it because this is also something different that I want to show you separately. So internal database data database config. So if you remember, internal data database config, this was a secret path that I need to access, right? So now I have set up access vault is the role name. So you could get confused. So this is not the service account name that I have written over here. Service account is over here. This is the role name over here that I mentioned. If you look at secrets access and under auth methods under Kubernetes, if you remember, we had mentioned a role name over here. So this is the access vault name. Sorry for the name ambiguity. I just use the same name everywhere, but not a good idea to do it. So now what I will do is I will just patch it. So I already have a patch command ready. I just paste it and I patch the deployment. So now what will happen is if you do kubectl get pods, and now we have two of them running. Now if you see kubectl logs, by this it will default to the running container. So right now if you see this is for the container, but we have another container by the name of vault agent in it. Now if I want to see this hyphen I think it's hyphen c, and I do this, now I will get the logs of other container. So if you see at this thing, it created a file sync, it tried to create a path, it took the agent configuration, API address and everything from buffer. It did all its internal process and got the auth token and everything, and got my secrets and injected it as well. How can I confirm? I will just click on over here. So if you see right now, this would be having something database config.txt. Now I want to see if my data has actually come or not. So we will just go inside that file because this is a file I know. And instead of doing ls, we will read the file. We will do the cat command. And if you see now, it's slightly what I would say, not in a very readable format. So we will be slightly changing this. So now instead of just having this, I will be adding something extra for you. So now if you do this, now when you will patch this, then see the difference. Right now it's like custom metadata and stuff. So let's patch again. Once I patch it, we will see again if the pods are up and running. It just takes a few seconds for the vault to actually inject. So it went into a crash loop for some reason. Let's see why that happened. kubectl logs. It should not have happened. I am inside it, right? Internal database. Okay, so okay, got it. I understood. So because of this versioning, a few things happened. So let's do quickly one thing, because I do not want to go into it deeply right now. So let's just disable this one, and what we will do is we will quickly recreate it. So I might be having the command. Let me just vault kv command. So we will run first this, and so if you see, I enabled it again, and I have put so vault kv. So vault kv is the vault key value secret engine thing, and you can just run this command and get its all the help that you want, and you can use it. And now what will happen is, since I have already put it again, now if I see kubectl get pods, it's trying to initialize again. Now let's see, it's in the running state now. So now if I do run that command that we were trying to see inside the file, we will see a slightly different thing. Our data in a specifically structured format. User, if you see, it would be like PostgreSQL, like we are giving it a PostgreSQL URL. So PostgreSQL colon slash slash, this will be a string. If you see over here, then our username is picked from the cluster itself. Then the password is picked, and rest of it remains the same. It's up to you how you want to manage it. So that is how the access thing worked. And now yeah, I think this is all I had. I was not able to completely prepare the external secrets operator thing, so sorry about that. We can access, this is not the only method that we can access our application access the secrets from Vault. So there is something very commonly known, like if you're using multiple secret engines or multiple secret providers, there is something known as external secrets operator, a very commonly known tool. So you can configure Vault with that also. You can then also use SDKs. You can also use command line. Let's say I want to use a HTTP endpoint. I might have that, it's somewhere over here. So let's, instead of this, let me just quickly do one thing. We will go over here. We will copy the token, and so this is a URL that I had already written. Now, if you see, I'm trying to show you how to access it using API, HTTP endpoint. So over here, using HTTP endpoint, I was able to fetch the data. So yeah, these are all the methods. Like, this is a never ending thing. We could deep dive maybe next time, but yeah, this was all for this workshop. Over to you, Dheeraj.
Thank you so much, Ashish. So I guess that was a very good deep dive about the secrets that we were vouching for, right? Correct me if I'm wrong, Ashish.
Yeah, I wanted to go deeper. If maybe someday you give me a 4 hour slot, then I will go very deep inside it, everything about the vault.
So for that, then I would have to host a workshop in
Correct.
AWS UG
Yes.
meetup where people might come with their laptops, so they can do that practically with you. And in case of any
Yeah.
queries, they can reach out to you to
Yes.
understand what exactly are the steps, and you can help them at the same point of time, right? So I think that was actually exhaustive and very deep dive session, because I was actually also going through about the concepts that you were actually talking about uh, on the other hand, on my other screen, that what exactly this secrets are, how you're utilizing it, what is you also spoke about the Hashicorp cloud, where we get $50 when we are registering on that. So all these things I was actually trying simultaneously, because I am also interested to know how we can host secrets, that is AWS EKS secrets, onto Vault. That would be a central kind of repository, or a central kind of secret management thing that we can utilize for multiple pods which are hosted in AWS EKS clusters onto our worker nodes. So really overwhelmed with the knowledge that you have shared. Thank you so much. And is there anything else that you would like to share with the viewers who are checking this out? Like, if they have any questions or something, should they reach out to you on LinkedIn or some other channels?
Yeah, sure. So one thing I definitely missed was the secret management that we talked about. It was around Kubernetes, but the vault that we have hosted, it can be accessed for various other reasons also. I store my personal passwords in Hashicorp Vault and Zoho Vault. So I'm using it for my personal self-hosted thing also. If you want to use it on something else, like, there are ample possibilities, ample use cases possible. You can look out at the Hashicorp documentation. They have this section of 22, 23 workshop kind of things, which you can try and get ideas and create ideas out of them. And if you have any doubts, I'm just uh, uh, I'm not sure where should I put the links.
So
Or
you can put the link in the chat on the right hand side. There is an option of
okay,
chat. Over
okay,
there,
great.
you can go ahead and put the link.
Okay, let me just,
So whatever link you are interested to share, you can go ahead and share it over there.
sure, just let me copy that and that. Okay, so I cannot actually send messages in stream, so I'm sending you to you on private, and maybe you can share it ahead.
Okay, definitely. So let me. So that is the LinkedIn that you are looking for. So can you also share the workshop that you're talking about the Hashicorp, that people can go through that?
Yes, I have 2-3 links already open on my end, so let me just quickly share them. So these are your 22 tutorials actually. So it will help you set up like ample of scenarios that you want. And for installation, like this also includes the installation. And if you want to have the overall vault documentation, then this is your overall vault documentation. Inside this, like they have like this is one of those documentations that you would like, because there are a lot of documentation that people don't like. So yeah.
And as you have set up AWS EKS cluster, so for that, is there any workshop or something that any documentation you would like to share?
There are workshops, but I have not used them. So what I will do is I will be sending you the codes that I have used, the Terraform codes, and maybe you can just upload them to a GitHub repo.
Okay, definitely. So just give me 1 minute. Let me. Okay. So yes. So yeah. So I was actually looking for that link that I was talking about. Unfortunately, I'm not able to find it. So what I can do is I can share it later with the viewers so that they can utilize that AWS EKS workshop by using which they can set up their own EKS cluster and try out the solution of the vault that you have provided. And meanwhile, I will also upload it on GitHub, from where they can check out the solution and they can try this workshop at their end simultaneously while watching the video after the stream is ended. Okay, so thank you, Ashish, for taking out your time and sharing your knowledge across the community, showing them that how we can use it. So before we close, do you have anything to add?
No, just thank you so much for inviting me. This was my first time, so yeah, glad
Okay.
you asked me.
Yes, that's awful. But you are fantastic. You have given a tremendous workshop. I really loved it. So no need of telling that. Thanks for inviting me, because well deserved, man. Well deserved.
Thank
So
you.
see you soon.
See you.
Bye
Bye
for
bye.
now. Yeah.